Hi everyone, welcome back to another episode of the PICO VR development series with Unreal Engine. In today's video, we'll show you how to increase the levels of immersion of your VR application by replacing the virtual controllers with a set of 3D animated hands. So let's get started. By the end of this video, you'll have a solid understanding of how to add VR hands in your application and go from something like this to this. Having VR hands enables you to reach out, grasp objects, make gestures, and engage with the virtual environment using your own hands. So grab your PICO headset and follow along. We will show you how to import your own custom hand 3D model assets and how to add them to your pawn using skeletal mesh components. After that, we'll explain the basics behind the animation system by explaining how to drive the animations from the player input. Finally, we'll add an option to easily switch between VR hands and VR controllers. We'll provide instructions for both Unreal Engine 4.27 as well as Unreal 5.1. So grab your PICO headset and follow along. The first thing you need to do is follow the link in the description to download the hand mesh and hand animation assets. These are provided as part of Unreal Engine 5 VR template scene, but Unreal Engine 4.27 doesn't have them, so that's why we'll use them here. Once you have downloaded the file, unzip the contents and open Unreal Engine. Go ahead and create a new folder and rename it to Hands. Navigate to where you unzip the hand assets zipped file and open up the folder. Now, grab the asset called skm_right_hand_fbx model and drag it into your project's content browser. You will see a pop-up asking you about the import settings you wish to use. Make sure you use the same settings as the ones you see on screen. You can change the color of the material used in the hand mesh to make it bright yellow instead of using the default gray, and then save it. Create a new folder and rename it to Animations. After the mesh is imported, we now want to drag all of the animation files in as well. We do this after the main model is imported, so we can use the same skeleton as the skm_right_hand mesh. Once you do this, you will see another pop-up on how you want to import the animations. Make sure you set the skeleton to the same skeleton we imported earlier, which is skm_right_hand skeleton. After that, click Import All. Animation blueprints are specialized blueprints that control the animation of a skeletal mesh during simulation or gameplay. Right-click on the skeletal mesh and create a new animation blueprint. Rename it to ABP Hand. Open it and then go to the Animation tab. At the bottom right, you can see all of the imported hand animations, and you can click on each one to see exactly what it does. Hand idle right is the default idle hand pose for when we don't press any buttons on the controller. Hand grasp right is an animation for when we press the grip button on the controller. Hand index curl right is the one we need to use when we press the trigger button. Hand point right is the one for when we touch the trigger, and finally hand thumb up right is the one we need to use when we touch the thumbstick or any of the A, B, X, Y buttons on the PICO controllers. Now let's go back to the animation blueprint and go ahead and create 6 float variables that are going to be used to drive the animations. Now we're going to modify the event graph so that the variables current pose alpha thumb up and current pose alpha point smoothly interpolate towards the values of pose alpha thumb up and pose alpha point respectively. This way, the finger movement animation will remain smooth during sudden changes to the input. Make sure the interpolation speed is set to 13, and don't forget to connect the delta time parameters. Next, we're going to modify the animation graph, which is what we will use to control and blend different animations for the hand. This will decide the final hand pose animation, which will be used according to the values of the 6 parameters we defined. Drag and drop one by one each imported animation within the anim graph. First, use the idle right and grasp right nodes and make them blend together according to the value of pose alpha grasp variable. The closer the variable value is to 0, the more the final animation will blend towards the idle pose, while the closer it is to 1, the more it will blend towards the grasp right pose. Connect the output animation pose to a new animation node called Layered Blend Per Bone and click Add Pin to add an extra blend pose. Make sure you connect point right animation to blend poses 0 and thumb up right node to blend poses 1. Then we will connect current pose alpha point to blend weight 0 and current pose alpha thumb up to blend weight 1. Use the output animation pose and add another layered blend per bone node. This time, use the index curl right animation node for blend pose 0 and connect the pose alpha index curl variable as a weight. We need to make one more change to the configuration of the layered blend per bone nodes to make sure that the animation passed can be combined properly to only affect a specific subset of the bones in the hand skeleton. These nodes perform a masked blend that only affects a specific subset of the bones in the skeleton according to the configuration settings. Since the hand point right animation node only really animates the index finger, we need to add the bone name index_metacarpal_r to the layer setup, so the final animation output only takes into account that particular index finger bone. Likewise, the thumb up right animation has to do with the thumb finger only, so we need to add the bone name thumb_01_r in the layer setup. For the second layered blend per bone node, the index curl animation is only about the index finger, so again we need to define the index_metacarpal_r bone name as the bone base that will be affected by the animation. After connecting everything together, you can now preview how the hand animations will work as the float variables change using the animation preview editor. Go ahead and change the values from 0 to 1 and watch how each one affects the final hand animation in a different way. Also, the reason we use the smooth interpolation for pose alpha thumb up and pose alpha point is that this way when the input changes the values of these variables, instead of having the finger suddenly change to the new position, the current pose alpha thumb up and current pose alpha point variables will be used for the animation to smoothly follow the final input value and animation. After finishing up with the hand animation blueprint setup, it's time to add the skeletal mesh component representing the virtual hand to the VR pawn and connect the input actions to update the variables defined in the animation blueprint. Create a new skeletal mesh component under the motion controller component and name it hand mesh left. Do the same for the right hand and name it hand mesh right. Set the skeletal mesh for the new component equal to skm_right hand for both the left and right hand controllers, but change the Y scale of the left hand to -1 to flip the right hand model and make it become a left hand. To make sure the virtual hands are aligned with the controller positions so that they appear in the right position and rotation, use the following transform for left hand and right hand. Next, make sure that the new components we added use the animation blueprint we created earlier, so set the animation mode to use animation blueprint and the anim class to ABP hand. Now let's modify the VR pawn blueprint so that the variables we added in the animation blueprint are updated based on the user input from the controllers. First, we need to cast the animation instances for the virtual hand skeletal mesh components by promoting them to variables on event begin play of VR pawn. Then, in the input settings, we need to add some extra axis mappings for the events that occur when we touch the trigger of the controller, or when we touch the thumbstick or A, B, X, Y buttons of the controllers. That's because we still want an animation to be activated every time we touch those parts of the controllers, or we release them. Go ahead and add 4 new axis events: left trigger touch axis, right trigger touch axis, left thumb touch axis, and right thumb touch axis, and add the corresponding PICO touch events. After adding the input axis events, we can now connect the input events to the cast animation blueprint references, so that every time the player interacts with the physical controllers, the virtual hands will respond to the input and move the fingers accordingly. Feel free to pause or slow down the video to follow the changes we are making in this project. You may also want to change the transform of the pistol blueprint's grab component to make sure it aligns with the virtual hands. We're also going to make a small change, introduce a new Boolean variable, show controllers, that you as a developer can manually change depending on whether you want the VR pawn to use virtual hands or virtual controllers, but not both at the same time. That's really easy, as we can just hide the set of components that are not currently in use. So go ahead and create a new Boolean variable in VR pawn called show controllers and make the following change. If you are using Unreal Engine 5, then things are slightly simpler since the VR template scene already has virtual hands added to the VR pawn. However, the hand animations will not work with PICO controllers unless you modify the input mapping context imc_hands and add the required control bindings for PICO touch controllers. Go ahead and add the right control bindings. Feel free to pause or slow down the video and follow along. It's worth noting that there is currently a bug in Unreal Engine 5, and so when both IMC hands and IMC default are added with the same priority, input events are consumed by IMC hands first. So the IMC default actions like grabbing stop working. To fix this, open the input action hand grasp left and hand grasp right, and make sure you untick the consume input field. This will fix this bug. Also make sure you change the virtual hands transform so that they are the same as the ones you see on screen. If you also want to be able to switch between VR controllers and VR hands in Unreal Engine 5, you can follow the same steps as before, but make sure that you only assign either the input mapping context hands or the IMC_controllers mapping context, depending on the value of the Boolean variable showControllers. That's all for today. Now you can package and run your application and you'll be able to see your virtual hands render and respond to your input actions, which can greatly improve immersion for your VR application. If you enjoyed this video, make sure to give it a thumbs up and subscribe to our channel for more exciting tutorials. And follow us on Twitter to get the latest updates about the PICO SDK. Thanks for watching.